TESARREC is an online resource to enable calculations to estimate technical, environmental, economic, and social performance assessment of renewable and bioeconomy systems. It has two main platforms, Model Bench and Sustainability. Model Bench, under development, will allow you to solve your own formulated set of equations of any kind. And under Sustainability functionality, by the drop-down menu, you will get access to inbuilt models of process technologies to test effects of inputs on output variables in those process technologies. Soham Sen, IT analyst, and in his GitHub account, you would be able to find the JavaScript code for this program. By the drop-down menu on Sustainability, you will be able to access the standard models of the various processes in biorefinery and renewable systems. Microbial fuel cell, MFC, microbial electrosynthesis, MES, combined heat and power, bioethanol production from biomass, chemical production from biomass. The aim of this video is to show the main features of the sustainability platform of TESARREC. Let's look into microbial electrosynthesis as an example to see the main feature that has been followed throughout all the modules under sustainability. On the top corner, you would find a readme documentation that gives all the basis of modeling equations you need to know for the given process technology. That would help you to create your own model and compare the results against the model. And also, you would be able to fit your. On the right, there are user inputted variable navigation bars. Their values you should access completely by scrolling down, by expanding the various tabs, for example, environmental and cost parameters, and accessing all the values. For this process, microbial electrosynthesis, this is to remove impurity from wastewater in the anode and volatile fatty acid production from the cathode by carbon dioxide utilization in the cathode chamber. In this process, the product options considered are formic acid, acetic acid, propionic acid, butyric acid, caproic and valeric acid shown in the various rows in the heat map. Substrate options are acetate, glucose, lactate, propionate, pyruvate, sucrose. From the concept of heat map, the darkest colors would reflect the hotspots. Minimum level, you expect to see the technical process performance, such as production rate, the environmental performance, such as global warming potential saving by the new process displacing the old or existing process, cost parameters such as capital cost, operating cost, cost of production or minimum product selling price, the discounted cash flow analysis. Furthermore, in other modules, you would find social life cycle sustainability assessment comprising labor rights and decent work, health and safety, human rights, governance, and community infrastructure as the main criteria to compare against the base case. The various capital cost items for the microbial electrosynthesis process include anode, cathode, membrane, and current collector. And from the default value of membrane, you can see that membrane is the hotspot for the cost. For example, if we notice the cost of production of the product or the minimum product selling price, and if we lower the membrane cost, then you will see the cost of production is also decreasing. Similar effect you can expect on the discounted cash flow analysis. With lowering membrane price, the payback time will also be lower, and with increasing membrane cost, the payback time will increase. For all the capital expenditure was spent between -3 and 0 year, and 0th year is the startup for the plant. After the plant is built, the plant starts producing the product, and therefore there is increasing slope for the net present value after the 0th year, and where this curve crosses the x-axis or the 0th axis. That is the break-even point to recover all the capital investment, and after that the plant will start making money or will make a profit. This discounted cash flow is very sensitive to the membrane cost, as we have seen before. Lowering the membrane cost will lower the payback time or the break-even time. Also, the Lang factor that is applied or multiplied with the delivered cost of equipment is another very sensitive parameter, and reducing that, lowering that, will lower the payback time, will make the plant more economically attractive, and these are the prominent effects of the economic analysis. The economic analysis, as said, gives all the detailed calculations on capital cost, operating cost. Please do access the readme document by downloading. This first gives the background of the process. As discussed here, microbial electrosynthesis systems are a technology for simultaneous removal of chemical oxygen demand or impurity in wastewater in anode chamber and synthesis of products in cathode chamber by harnessing oxidation and reduction reactions by the application of an electric field between an anode and a cathode. Detailed process descriptions are first given, then the steady state overall reaction equation model will comprise overall stoichiometric reaction. From the stoichiometry, the elemental balance equations, thus the production rate calculation, the Gibbs free energy of reaction calculation, and the theoretical potential calculation. Techno-economic analysis is very detailed. That includes the capital cost overall equation, which is dependent on the delivered cost of equipment, the net present value calculation. Operating cost has two items, fixed and variable. Fixed operating cost is dependent on indirect annual capital cost and labor. The case study is shown here for the default values. The various tables give the input values as well as the output results. This is a must-read document to get the full understanding of the modeling scope. It will help you to adapt the model, to develop your own model, and then standardize and test your model against the published results. Reference 1 is very important here because it gives the basics of the economic analysis calculations, environmental and social sustainability analysis calculations. On the reference tab on TESARREC, you also will be able to access the references to build the models. TESARREC is expanding, and we are keen to hear from you on new or existing technologies. Please do contact us as shown here if you have a new idea and you want to work with us in new model creation. Looking forward to collaboration. Thank you.